Right, today is a big one. Underneath me is a high voltage battery pack out of a prototype EV bus. There's very little information on the pack. Odd specifications are available, but no one really knows what is inside. So today I'm going to strip this thing down, see what's inside, show you all the connections, the modules, and go from there. So it could be fun. So let's crack it open. This battery is made by a company called Proterra. They make specific modules for a stackable high voltage system where you can use multiple packs. They are specifically used more for the EV bus industry, but I'm very interested to see how these modules are configured so I can use it in other projects. The specification I have is it's 215 volts, 72 kilowatts. So this type of system, it can be incredibly dangerous. The high DC voltages that these packs have touch the wrong thing and it's going to kill you instantly. That is why there are a lot of things in the EV world to try and make this safer. When you're splitting a pack though, you are entering that part where you're going past the safety procedures that the manufacturer is there to protect the general public. This in a shell is absolutely fine, but split it open, it gets much more dangerous. This is not a how-to video, this is showing you what is inside. I do this as a job, I have all the necessary safety equipment that means that I am protecting myself as much as possible. If you want to be able to do this type of work though, there are plenty of courses out there that you can do it with. Felton, that's where I did my training. They do different levels depending on what you're planning to do. Levels 2 and 3 start getting more technical. Level 4, which is the highest one that I have, is more on a technician level, which is pulling apart actual batteries and modules and doing things on that side. So make sure you do it safely, and I'll be putting all my safety gear on now to start opening this up. So the first thing that I need to do is basically get to where the contactors are. So inside battery packs you have contactors that the ECU side of things and battery management systems click in and out to start sending high voltage out of a battery pack. I have to assume at the moment that these contactors are stuck on because that's your worst case scenario where the terminals are still live. But to get to those, different batteries have different sort of entry points. On this, the Proterra is actually a very nice system because it's in a cast aluminium casing on the outside. You can just see under there, that is your contactor, well, your outputs. You've also got some connections which will be for cell taps and monitoring temperatures. So first of all, I need to open up this case. So it's gloves on and take out all the bolts around the edge. Now looking at this, the seal has been broken on this before. So someone has got into there. There is usually a fuse system in there. So there should be a fuse, but let's crack it open and see what is in there. Okay, so I've got my multimeter there that you can see. So essentially the way that this pack is situated, you've got a red terminals, so you would generally say, okay, that's a positive terminal, but that's coming in. This is your safety disconnect. That is disconnected underneath. I don't have the connection for that. So essentially the voltage should be stopping there, but you can never assume that. Buzz bar comes around through there, into a big contactor. You've got a secondary contactor there that might possibly be a pre-charge relay, and what that essentially does is it opens up using a resistor a smaller amount of voltage to go to the actual inverter to charge the capacitors up. If you put full pack voltage straight to a capacitor, you're basically going to kill them fairly quickly. And so it goes through to your little pre-charge one. Now, it's a nice safe system in a way, because as you can see, you've got a live bus bar essentially that you can touch. On the other side, the contactor is actually situated right at the side, so you've got the same sort of negative terminal coming in like you do with this positive side, but it's actually coming in and it's behind a cap. But I can actually just about get my multimeter onto one of the smaller connections, and if I go around to there, we have a pack voltage of 235 volts. So I think that is pretty much fully charged, because from the specification I was given, or what we think it is, we were saying it's a nominal of 215. So a pack voltage of 235 is pretty good. Now I can test from the other side to see how dead it is. As you can see, on the other side of that, we have absolutely nothing. So we know that that safety disconnect is working, because all the way through the system, these voltages are nothing. So that's cool. So we know that basically from a electronics side of things here, it's pretty safe to be working on, but you still have high voltage terminals in there, so it's incredibly dangerous. I've got my 1000-volt gloves on and my external gauntlets, just to make sure. Next thing to do then is the top plate. So it's undoing all of the bolts on the top, and then we can actually see what the individual modules are, because at 235 volts, 10 of them, then you would ordinarily say that if they're all in series, as it's in series, they sort of add up voltage wise. So 10 of them, you're looking at 23 volt packs, 24 volt packs. They could be in series and parallel though, who knows, to get the capacity. So I'll split the pack and see how it's configured inside. There are a lot of bolts on this. Let's go. Now the seals on this, the actual pack, it's not been opened since it was put together. But the pack being 235 volts would indicate that it's actually in decent nick. Now these batteries, to cope with temperature, are water cooled. So there's a couple of external hoses that stick out, and they have almost like a glycol mixing. So it'll be interesting to see also how the cooling system is actually plumbed in on these, because one of the things you've got to be careful of is if you are disconnecting individual modules, if it's got coolant in there and it spills out over one of your packs, you're not really worried about the electrical side, because the packs are only 24 volts each. You can't, it's going to hurt when you touch it, but it's not going to kill you. But the water or glycol can kill the battery. Then you've got a dead module. These central ones that I'm doing now are actually, I think, screwed into the cooling plates on the modules. So it means the modules are very well secured. It means that you can store it upright, on the side. Pretty cool. So the pack, I've unbolted it all. Now it's got a sealant on there, obviously to stop water ingress. So trying to break that seal open is going to be the next little challenge. With the energy storage applications that we do with these packs is taking Second Life EV batteries and actually storing them and using them for energy storage. Felton do a charge cube, which is a very, very good system for that. And so I'm hoping that some of these batteries I'll be able to utilise for energy storage, but I also want to break it down to see if I can use it for classic car conversions. The big reveal. So what you can see here is basically there are essentially 10 modules. So you have a bank of cells down one side. These are like a vermiculite panel that essentially just increases the sort of fire rating of somewhere, very, very thermally efficient. And so there'll be another line of batteries down that side. So you'd essentially then have, that is one module. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 modules. If they're all in series, then that makes them 24 volt modules, which is a sort of standard output for these, but I'll take the vermiculite off now, off one of the packs, see what it's like. So now we're on the internal sides. We know that this battery pack has like 230 odd volts in it, so insulated screwdrivers and things now, just in case you touch a terminal on there. And so there it is. That is one of the vermiculite panels taken out from there. And they are just one big long module. And you can just see they're very well guarded down there. And the buzz bars each side. Might be able to see it better this side actually. So you can see there, there's a link between each pack. So that'll start giving me an idea on the voltages. If I can get a connection down onto one of those, I can start just sort of checking the individual module power output from it. So I've just been checking over, here are two of them together. Now down this side is where it all sort of connects up. So we know that we've got the main positive terminal just on the inside there. So that runs through and connects to this first bar. So having a look at the configuration, it actually runs all the way down, has a small link to link back through the module and comes all the way back to here. So testing the voltages at this side on those two terminals, I do get just under 24 volts. So that single pack is 24 volts. Testing the next one, I get to nearly 48. So they are stacked up basically in 10 series, and they go all the way up to the end. And then essentially, because this is your last essentially negative terminal, there is actually a high voltage cable that then connects and runs through this channel. You can see it just there, and it actually goes in, it's nice, it goes into an aluminium ducting, so you've not even essentially got the cable flapping around in the pack. It's secure in its own channel that runs just all the way down this side, comes through to your negative terminal, and your contacts are in there. So very nicely put together, heavy duty system. You know, for a lot of cars you wouldn't ordinarily what would I say, make the casing so robust. Now to get these out, which I won't do in this video, but essentially there's end bolts that go in each side, and that releases it. The only thing is, I don't think that is going to pull out without taking the end casing off. So this end comes off. Your coolant side is all the other side, so you can almost keep that there and pull it out. So the only thing I want to do now is investigate what the cell taps are like, to see how it reads things, to see how we connect our own BMS system to it. But on that note, that is the end of this video. Pretty exciting really to be able to split down one of these modules and see what's inside. I will now evaluate the pack in general, see what it's like, maybe split it up. Some of you may know that I am going to convert an MGB GT to electric. Some of these modules might be there. Them being 24 volts, essentially, if I get 4 of these, that will give me, let's have a think. 4 of them will give me basically 100 volts, which is good for, say, a net gain Hyper 9 motor. Because here is the MG. It's in nice condition actually, needs a wash. But that essentially could have 4 modules in there, giving it, if this is a 72 kilowatt pack, that means they're 7.2 kilowatts per module. So we're talking 7.28, 29 kilowatts of power, which is actually a very decent amount of power for a classic car range. That is another video though. So there we go. The pack has been broken. There'll be more videos on this, some exciting things to come. So make sure you like and subscribe. And until next time, stay safe, people.